Hello, everyone, and welcome to today's webinar on understanding KVM technology and the benefits of this technology. My name is Bo, and I'm product manager at Convena. Before we start with the actual topics of the day, I just want to go through a few housekeeping items. Throughout the webinar, you will all be muted to ensure that we have a smooth presentation. Feel free to put your questions in the chat box on the right-hand side of your screen. We will read out questions to the panelists team at the end of the presentation. We will also be recording the webinar, and the recording will be made available to you all beginning of next week. Now let's go to presentation of who is Convena. I guess most of you already know that. We are an international IT distributor with most common spare parts, options, and accessories, and we keep 10,000 items. 10,000 plus items in stock and have access to more than 300 items throughout our partner agreements. We make 24-hour delivery in Europe and 48 hours to the rest of the world. We have local offices in 5 different countries. So besides Denmark, Sweden, Holland, France, and the UK, and in total we're able to speak 17 different languages. Right. So yeah, why this webinar? This webinar is to give you an insight to what KVM is about, and yeah, I'll just pass on to Fredrik from here.
Good morning. Can you hear me? Right. Sorry about that. A little bit of technical issues there. Just to kick off, thank you very much to Convena for setting today up. So thank you very much. Really appreciate it. And thank you to all the attendees that have registered. And I mean, no doubt that today is going to be a really good session and a very clear understanding in terms of black box KVM product portfolio. So our mission statement really is we want to help clients manage complex signal management and distribution challenges in the IT and communication systems. And we believe that we can do this via the right partners. And we believe that the Convena and the resellers in Denmark are going to be able to help us achieve the goals that we want to achieve around growing our KVM portfolio within the IT industry. A little bit about Black Box. So we've been trading for circa 40 plus years. We started in the US. So our head office is actually based in Pittsburgh. We have worldwide coverage, so we are an international business. And our 2 sort of key focus areas that we live, breathe, and eat is absolutely KVM and AV. We also have additional products that we've got to our portfolio, such as networking, cabling, and this is all sold through our chosen distributor in Denmark, which is Convena. We offer post and pre-sale support. So again, off the back of today's session, if any of you identify that actually there is an opportunity with one of your customers, Black Box have a team that can come and support you along with Convena to go and demo the solutions, provide demo kit, and really help you through the process. That's a little bit about Black Box. And again, thank you very, very much for participating on today. Why Black Box? And sorry, there's a bit of a delay in the screen. So just from our side is, why did we choose Convena to be our chosen distribution partner in Denmark? Is that we believe that Convena has the breadth, the reseller breadth. They have a great team that can support the reseller network. They're in a good location. Convena offer us a great footprint across EMEA because that's really, where our focus areas are. And Convena's doing really, really well in terms of, grabbing hold of the Black Box portfolio and driving it across all of the resellers within Denmark. They've got great stock profiles. So one of the things that we've really been working hard on is that we want to provide customers with good service level, good stock level, so that if any of you do need stock, that you can place the order with Convena and know that you would be able to achieve next day delivery, and better lead times where, as a Black Box standalone, we weren't able to react as quick as what Convena could. And again, Convena are great in terms of joining, in terms of working with us in joint activities. So, we're doing a lot of work around training Convena sales team. We're happy to do joint marketing campaigns with Convena, with yourselves. And again, just to drive home the fact that, we have a Black Box team that can go out and help you with demonstrations and visits to your customers. I'm going to hand it over to Casper because I think Casper may want to add a little bit more to the Black Box and Convena partnership.
Yeah, hello, this is Casper here from Convena. It looks like it's Bo speaking, but we're using the same microphone, so that's the explanation. So we've been working together with Black Box for quite some time now. We are very happy with the way it's evolved and looking forward to what the future will bring. We're not going to go so much into that today. So I'm just gonna say that we are very satisfied with the way things have progressed. And after this presentation, you'll be able to contact me directly if you have any questions, you need a quote, you have anything you were wondering about. You'll also be able to contact Black Box directly if you have any technical issues. So if anything, please call me, send me an email, write a chat message, whatever. I'll be available for you for anything. And okay, I think I'll put you over to Bo now, who's gonna go a bit more into the webinar now.
Right. Sorry, Bo. Just before we carry on, I'm not sure whether we touched upon this, but if you have any questions during the session, there is a chat functionality. Please send all your questions over. At the end of the presentation, somebody will read out those questions and Brian will be able to answer.
All right. So today's webinar will be presented by Brian Andrews. He's an application engineer at Black Box based in the UK. And he has more than 10 years of experience dealing with large KVM and Pro AV projects. And so he will be the ideal person to take you on this KVM journey. So Brian, take it away, please.
Thank you very much indeed, Bo. Good morning, everybody. I hope you're all well. I hope this session is going to be quite informative for you. We've got a few other sessions lined up afterwards. So today we're going to be covering understanding KVM technology and the benefits. And then on the next session, we'll be doing direct connect KVM versus KVM over IP, which is something that we touch on a little bit in this session, not too much. And then on September the 26th, we're doing the KVM Solutions Update. If any of you decide that you would actually like further information or go into anything in any depth, if you contact Convena, then they can get hold of me, or you can email me direct, and we can always set up some direct webinars to give you further technical training. Test. Can everybody hear me okay?
Yes, Brian, we can hear you.
Lovely. Thank you very much. We seem to be having problems with a mute function putting itself in automatically and unrequired. So today we're going to cover analog versus digital video. We're going to look at what is KVM switching and what is KVM extension, and then where they're used, and then elements to improve video quality and transmission distance. So this is the first session of what will hopefully be many training courses for you. And as such, we're going to start off fairly light, and as the sessions progress over time, they'll get a little bit more technical, a little bit more salesy, depending on what you need. So, analog versus digital. We're going to have a quick look at some of the old standards just to cover them and remind ourselves of what some of this stuff used to look like. So, initially, we had UHF transmissions. Now, this is basically a cable with a single center core where audio and video were being transmitted down one piece of single copper, which had a bit of shielding around it. We then have the composite video standard that separates audio from video. We then moved on to S-video standard, which began to break the video signal down into components, and in this case they broke it down into what was called chrominance and luminance. Chrominance being color, luminance being brightness. And separately to this cable, you would have your separate audio and video cables. This then improved when we moved to component video, where we broke out into basically color difference, and color difference 2. Everyone looks at these connectors and thinks they're red, green, blue, so it's an RGB signal. It wasn't. It was slightly different to that. But we've now broken the video signal down into 3 separate components. Finally, within analog, we moved on to the VGA interface, which actually breaks out the signal into 5 separate components. And in this case, they are true red, green, and blue, so RGB, and then a separate cable for horizontal sync and a separate cable for vertical sync. Now, what's actually going on here over time is that we're discovering that the more we break down a video signal into its basic components, the better the quality of the picture. And also, the longer the distances we can transmit that picture over and still maintain its integrity. However, analog does have its limitations, and some of those, certainly when we look at the VGA interface running high resolutions, it's a very noisy interface. And so over the last 10 years, there's been moves, change from analog signals into digital. And hopefully you'll have seen this happen even, in your office and at home. So the three main video standards around currently, in the top right-hand corner, we're looking at our good old trusted HDMI interface. Below that, we have the DVI interface, of which there are about 5 different flavors. And then we have on the left-hand side, the DisplayPort interface. Now, all three of these interfaces are able to take much higher resolution images and transfer them from a source to a screen. DisplayPort and HDMI are actually capable of taking things much further than the DVI interfaces. So DVI is probably not going to receive much more development, but HDMI and DisplayPort are going to continue to be developed for some time. So this gives you the basics of the video interfaces. Analog, very basic, our first foray into video. That UHF signal has been used on television sets since the 1950s, and it had its limitations, but at the time they were irrelevant. As time's moved on, we've gone right the way through lots of different analog signals and then on to digital signals, and now we're developing those digital signals as much as we can. This is all great when using everything locally, but sometimes what we want to look at is somewhere else in the building. And we often need to control these devices. So this is where KVM technology became used. So KVM is a short-term phrase for keyboard, video, and mouse. And it breaks down into two defined product areas: extension and switching. And extension breaks down into two further areas as to whether you're going to just run a direct connect system, which may make use of the company's structured cabling system that's installed, but is not network-based, so it's a plain point-to-point extension, or IP-based extension, where we're actually part of the corporate network or a parallel network to it. So within the analog arena, what we tend to do when we're extending video signals is convert them into red, green, and blue. So whatever may be coming in, whether it's UHF or component, but very much predominantly VGA, what we do is we take the two separate sync signals that I spoke about, horizontal sync and vertical sync, and we shove them onto the green pin. We then have the red and the blue pins, and we take these signals and convert them to a balanced pair interface, which we transmit over Cat-X cable. Any audio RS-232 or USB signals are then transmitted over the fourth pair. Most structured cabling systems should have all four pairs installed in them, and we make use of all four pairs to transmit analog signals over, using the first three pairs for color and the fourth pair for control. Now, if we're integrating into some kind of IP system, what we first have to do is filter the analog signal to clean it up so that we don't waste valuable IP bandwidth digitizing noise. So we filter at source and then we digitize them to an IP stream. Now, some of the systems don't return the digital path back to analog. It's quite common these days because most monitors will support an analog input and digital inputs, that when we're extending an analog signal, we'll convert it to digital because because it's better quality to transmit over long distances, and then we won't convert it back to analog at the other end, so we keep it digital all the way through. Now, one of the effects of poor quality video is that you begin to lose sharp edges. And this slide highlights this quite nicely. You're probably all sitting there staring at this, wondering why it's moving around on the screen. And the fact is, it's not moving at all. It is a solid image, but it's been designed that there are no sharp edges on it, which means that the eye is scanning that picture, trying to find sharp edge to focus on. And because it can't find a sharp edge, your eye is naturally darting about. This causes the image to appear to move. Now, this is a great little toy and a little optical illusion, but this is a problem when we're extending video, because if we don't present the user with sharp edges and clear text, you're going to get a headache very quickly. The image is not going to be clear to read, and extension basically fails. Now, this can often occur when we're transferring analog signals over Cat-X cable. And the reason is that these first three pairs that we use to extend the video are of different lengths. So when we convert red and put it down pair 1 and green down pair 2 and blue down pair 3, we end up with the colors being separated. And that gives us a blurry image. Excuse me. So a lot of our analog products have what is called skew compensation built in, where we take these three pairs and we match up the timing of the video signals so that whilst the signal itself is arriving at the receiver in a skewed way, we realign the three signals again and we get a sharp image. So to put this into a better context, this page is showing what happens with skew compensation switched off. And you can quite clearly see that the colors are all separated, the text is separated, the little Cat-X view the possibilities symbol looks very blurred. But when we align these video signals, everything falls back into place and we get a nice, clear, sharp image. So things we have to be aware of with extending analog signals is actually being able to adjust for the different lengths of cable that are used throughout a building. When we extend digital signals, what we tend to do is, first of all, reduce the number of pins. Because unlike a VGA signal, which, whilst presented on a 15-pin connector, we're only using about 10 of those pins. And we've got 8 pins available on an RJ45, so there's not too much we have to do to get all the signals down the cable. When we're looking at digital, we're looking at 20 pins plus. We've still only got 8 cores of cable on an RJ45, so we have to go about things differently. So we minimize the number of pins, and we use, for those people that are technical, a low voltage differential signaling technique. For those people that aren't technical, we just make it happen. Now, most digital signals have some degree of compatibility between them. So, for instance, HDMI and DVI-D are perfectly interchangeable. But some of the digital signals are not very helpful when it comes to playing in the playground with the other standards, and DisplayPort is one of these. It's a bit of a pain, so we have to use active adapters to convert between DisplayPort and analog signals, or even DisplayPort and other digital signals. So it's just something to be aware of, and something that we at Blackbox are very aware of. Now, when we're running extension, as I explained earlier, there are 2 main technologies that we employ to do this. One is infrastructure-based, and one is IP-based. So one is running through your actual network, running through your switches, your hubs, your routers. The other is not. It's just making use of the raw cabling system. The advantages are if you are just running through the raw cabling system, you can get much longer distances. So typically an IP network will never have a run that's longer than 100 meters because that's what the standard dictates. If we're running through a non-IP based extender system, we can easily get 300 meters. And this allows us to cope with quite older cabling systems within buildings and often make use of old telephone cable that's been run around that was never limited to 100 meters. However, in some instances, because the network is in place, we maybe get running in between two buildings on a campus. It's much better in these situations to use what is already there and working. So we would then use IP-based products to make use of the network. And that connectivity can then be converted to run over copper or fiber or wireless or whatever's required. So what is KVM extension? Well, very simply, the idea is that you take your computer away from your desk, and normally you would put it into a data center. Now, specifically, what we're trying to do is increase the distance that the keyboard, monitor, and mouse, and audio, if required, is away from the actual computer. So we're taking that computer from under the desk and the advantages which I'll go through shortly, and we're putting it somewhere else in the building. But we still want to feel as if the computer is right in front of us. So we've got the keyboard, the monitor, the mouse on our desk, maybe some speakers, a microphone, and there may be some requirements for other USB connectivity devices, peripherals such as drives, printers, scanners, cameras, USB sticks, whatever it may be. But these can all be supported when we're using KVM extension. Now this comes under the term of back racking. This is what a lot of companies are doing these days. Computers generate a lot of heat. So when you've got 30, 50, 100 people in an office, everyone's got at least one computer on or under their desk. These computers are generating heat, and typically they generate a fair amount of it. Because of this heat, the computers have to have some form of heat management system in, which is normally achieved through fans, and the fans make noise. The fans are sitting there near the power supply, generally dragging the hot air out of the machine and trying to get cold air into it. Your computer is on your desk. Therefore, if you're not sitting in front of your computer, someone else could be. So there's a bit of an access stroke security risk. Now, most of us get used to locking our computers up from the point of view of password protection when we leave our desks. But if anyone is in the office that really, really wants to hack your machine, it's not very difficult for them to sort of watch over your shoulder and see what password you're using. And finally, within an office environment, especially a non-paperless office, there's a lot of dust around. There's a lot of paper dust and all kinds of things. And with these fans going around in the computers, dragging air through, what happens over a period of a couple of years is a lot of dust builds up on the fans slow down, cooling of the computer becomes less effective, processors get hotter, and the computers fail earlier. So, pick that computer up, put it in the data center, keep the keyboard, monitor, and mouse on the desk, and all of a sudden, things become much better. The office becomes quieter. The office temperature becomes easier to manage and cheaper to manage because you're not having to employ air conditioning to reverse the effect of the heat being produced by all the computers in the office. Once the computer's in the data center, it's being kept in a cold environment. This is going to keep the processors working a lot more effectively for a lot longer. You'll actually be able to feel the benefits when you don't need to replace the machines so quickly. So there's quite a financial benefit to doing this over time. Also, the data center doesn't really care how much noise is going on because people are generally not working in there for 8-9 hours a day. So the noise of all these computers, all these fans, all these disk drives is now contained within one room. And that room will have access and security control on the door, so not anyone can walk in. So now the expensive bit of kit is protected behind what is normally heavy fire doors. You've got a bit more security in the building, which is good. And of course, the air in a data center is very dry. However, this does present some issues of its own. If all your computers are in a cold, noisy, access-controlled, dry air room, it's not actually very pleasant for people to work in. So even if you're not extending the computers from your desktops, you're just looking at servers in a data center, you don't want your data center manager to be having to work in that room for 8-9 hours a day. So yet again, KVM extension allows the data center manager to have access to every server from the comfort of his desk, where it's a bit warmer, less noisy, and the air is a bit more normal to breathe. So at the end of the day, back racking is an incredibly great idea. It means that you've got all the benefits of having the computer on your desk, but without any of the issues of noise, heat, the risk to security, and risking the longevity of your equipment. So some of the features and benefits that are available on some of our KVM extenders. There are situations where information is going to be displayed on screens, maybe in an office. Maybe you've got a screen hanging down from the ceiling in the middle of the office. Well, in which case you'll probably end up with 2 screens back to back. So quite a few of our extenders actually employ a dual output, so that you just put one receiver between the 2 screens. It will receive the same video signal from the same source, but split it and then allow people to read the screens from either side where they're hanging down from. A typical example that most people would relate to is a train station platform, where the screens hang down over the actual platform, but there's 2 screens back to back so that you can see it from either side of where the screens are, just giving better visibility to more people. Other extenders that we sell have a serial pass-through feature, and this can actually be used for switching screens on and off remotely, changing inputs, and indeed changing video resolutions. But the most common application here is to actually switch the screen on remotely at the beginning of the day and switch it off remotely at the end of the day. If the screens are up quite high, this means people don't have to get ladders out or try and find sockets hidden somewhere to switch the screen off. We would handle it all through the KVM extension system. A lot of our units support audio transmission. Some of them support infrared transmission, which will allow you to change channel of a source. If, for instance, you have some kind of set-top box or skybox, excuse me, that's maybe displaying news, and you want to change the channel, you would point your remote control at the screen in the normal way, and there'll be a little infrared receptor that's running through the KVM extender back to the source device, which is probably in the data center, but it allows you to change channels as if it was just sitting by the television. Now, some of the other interfaces can actually support extra features. So, for instance, HDMI can support up to 100 meg Ethernet. Not so useful in the office environment, but very much useful at home, because you're now bringing your broadband from wherever your source device is through to the back of your television without having to run an extra cable, and being able to now run those smart services that your television can provide, all the access to all the applications and extra features through this extra part of the HDMI interface, which will basically be taking the signal straight from your broadband router. Now, one thing I mentioned earlier is that the digital DVI interface is available in 5 different flavors. So if we start at the top, a single link DVI-I interface is capable of carrying analog or digital. So whether the video was maybe initially made in VGA or whether it's a true digital interface, a DVI-I interface is capable of carrying either. And they're available as 2 flavors, a single link and dual link. The difference is quite simply the resolution that can be displayed. So DVI-I single link is capable of reproducing video 1920 by 1080 or 1920 by 1200. So it supports full high definition video, as most of us use at home, and is a good standard. Within the office environments, we often get computers that are supporting dual link. Now this allows resolutions of 2560 by 1600. So this is a much higher resolution, and something that we tend to call 2.5K in the industry. If full HD is 2K, dual link is 2.5K. So it's a bit wider, it's a bit higher, there's a lot more detail on the screen, but we're not quite up to 4K standards. DVI-D will not transmit analog. It will just transmit digital video. And again, these interfaces are available as single link or dual link, and the same resolutions are supported. So single link is 1920 by 1200, dual link is 2560 by 1600. You don't have to memorize these figures, just be aware that if it says dual link, it's going to have more pins in the connector, and those pins are capable of transferring much higher resolutions. Finally, we have the DVI-A interface, which has now been deleted. It's analog only and is basically the same as a VGA interface, 100% analog, but it's just presented on a different connector. But this will actually show you the different pins that are being used, so you can pretty much tell that the left-hand side of that connector, where you've got what appears to be a minus symbol with 4 dots around it in the quadrants, that's the majority part of the analog signal. If we look at single link or indeed dual link interfaces with DVI, this is pretty much technically the same way as an HDMI interface works. So for those that are technical, it uses the TMDS link. For those that are non-technical, it uses Magic. But it basically allows 4 different streams of data to be transferred down the cable simultaneously. So you've got one pair for red, 1 pair for green, 1 pair for blue, and a 4th pair for clock. I don't think we'll worry too much about the rest of it. If anyone does want to get technical with this stuff, please let me know, and I can get as technical as you want, but for the purposes of today, I think you'll understand where we are. So this is just a little recap. Dual link DVI, which is typically written as DVI-DL. As I keep saying, it supports 2560 by 1600 at 60 Hertz. But it can also support lower resolutions at higher refresh rates. So it will support the same 1920 by 1200 interface, but at 120 Hertz as opposed to 60. And effectively doubling the number of pairs effectively doubles the amount of available bandwidth. So as I said, circled here are the red circles are around the main analog pins, which are red, green, and blue plus sync. And then the minus symbol that's circled in green is just basically a ground, and the ground is on all flavors of DVI interface. But whether it's an I, an A, or a D tends to be reflected in whether those pins with the red circles around them are actually prevalent. So you should be able to pick up a DVI cable, look at the end of it, and understand what that cable is capable of transmitting. Now, this can cause some problems because monitors that support DVI are obviously capable of supporting analog or digital. Graphics cards that run DVI can obviously support analog and digital. When a computer talks to a screen, there's a little protocol that goes on between the two of them called EDID. And they transfer a bit of information about what the monitor is capable of displaying and what the graphics card of the computer is capable of outputting. However, if both your graphics card and your monitor can support analog and digital, it can often happen that you'll end up with two EDID tables within the computer with the same interface. And then it's up to the monitor to decide which of these it's going to be able to relate to. So this is fine when you're just plugging a piece of cabling in between the screen and the source. But when we're employing KVM extension, the extenders need to be able to replicate these tables, and the extenders are only capable of replicating one EDID table at a time. So if your computer is trying to read two EDID tables from a monitor that's outputting two EDID tables, that can cause a few problems with extenders. That's where black box come in, because we know all about this. And I'm not going to go into too much detail on this, but basically, DDC is a collection of protocols that run between the computer and the graphics display, and within those protocols is the EDID information, which is a series of flags, and it'll actually tell the computer the manufacturer of the screen that's plugged into it, the model number of the screen that's plugged into it, physical size, the dot pitch, and the color ratios, the color gamut, and a lot of other useful information. So that information is an EDID stream which is contained within DDC. Customers often interchange these two terms, by the way, so be aware for that. If a customer is talking about DDC or EDID, they are referring to the same thing typically, but as a technical engineer, I view them as two slightly separate things, one of which is part of the other. Now, when we're extending interfaces over cable, this is where we start running into problems. If we're not using KVM extenders, cable length becomes quite an issue. And my experience is, if you're running 1920 by 1200 or 1920 by 1080, most cables up to 10 meters of length will work. Over 10 meters, you're on your own. It's going to be the luck of the gods as to whether it works or not. Anything over 15 meters, and quite frankly, you're really lucky if you get it working. Digital signals are not great at being extended on raw cable, which is why KVM extenders are so essential. Analog signals were much better. It was fairly common to drive a VGA signal up to 30 meters long. Anything over that, you needed a VGA extender. But for digital, they basically max out at about 10 meters. If you run a lower resolution, you can run a slightly longer distance. But I would always recommend, once you reach the limits of these, you need to be selling KVM extension. Some of the things that we need to think about there are starting with principles, because if you've got a DVI-D interface and you're going to plug a DVI-I cable into it, it's not actually going to fit, because there's no sockets in the interface to receive the 4 analog pins that are around that ground pin, those 4 pins that we showed with the red circles around them. If you've got those in the cable and not on the interface of the kit, the cable's not even going to plug in. So, physicals, you've got to get that sorted, first of all, otherwise you're not even going to get any connectivity at all. You then need to check whether DDC is switched on. Monitors allow DDC to be switched off, and if it is switched off, the computer's not going to know what the screen is capable of displaying, so it's not going to be able to output anything. and it will probably switch off the video interface and not even try. So it's quite important to make sure that DDC EDID is enabled throughout the system. It also, you need to know when it's being sent. Some equipment only sends the EDID signal upon power up. Other devices will send it upon what's called hot plugging. So if the cable to the monitor or the cable to the computer graphics card is unplugged and plugged in again, sometimes this will reinitiate EDID. Other times it won't, and then in which case you either need to reboot the computer or switch the monitor off and on again. You need to understand what's being sent. There are various tools that we can help with here, free tools that we can direct you to on the internet that will actually enable you to grab an EDID table from the computer, read exactly what was being sent to make sure it does make sense, that the graphics card could understand it and that it's valid. And that way you can understand what the graphics card's seeing, and if you need information about that, I tend to use a product called EDID Manager, which is a free piece of software, tiny little piece of software. There's plenty of others available. Just Google EDID Manager or EDID Management Interface, and you can download some free tools for that. But sometimes, whatever we do, EDID won't transfer correctly. And in these situations, we have what we call ghosts. So we take this device and we plug it in between our KVM receiver and our monitor. We put it in the circuit and we switch everything on. And the unit sits there and listens to the EDID table as the monitor transmits it to the computer. And we capture that EDID table within the ghost. We then switch the ghost off, remove it from the circuit, plug the monitor directly back into the receiver, and then you take the ghost and plug it at the other end of the link in between the computer and the transmitter. And now every time the computer asks for the EDID table, we don't have to wait for it to be received from the monitor running through the KVM system. Instead, we answer the request directly from the ghost. So the computer says, okay, I would like your EDID table. The ghost provides it, and that will be plugged in very close to the graphics card. And that way, we can negate EDID or DDC from causing any issues throughout the whole of the rest of the system. So they're a great addition to KVM extenders whenever you come across particular issues. So, some applications. Here we can see an awful lot of screens sitting in our broadcast customers' broadcast suites. That on this particular time, it's obviously a bit out day, so everything's just shown. There's an awful lot of screens there. Those computers are not all going to be within 10 meters, I guarantee it. So most of these signals will be transferred over KVM extenders. So the applications where we typically use these command and control centers. So, service systems. Emergency services. They will have an awful lot of monitors on their desks. The rooms are quite busy. You know, in panic situations, there's a lot of things going on. You need clear monitors. You want to get rid of all the noise in the room. You want to get rid of all that additional heat out of the room. You just want the people to sit there, hard work, be able to answer questions. Sorry, I've just been told there's a bit of microphone noise. I'm going to try and adjust the microphone. Hopefully that will improve. Yeah, you want these guys to be able to basically be as comfortable as possible so that they can deal with these panic situations quietly and efficiently. Things like railways, traffic monitoring, oil rigs, we provide thousands and thousands of extenders into, chemical plants as well. We also do huge amounts of business with the broadcast sector. Now, broadcast traditionally has kept its servers in the actual studios. So where the person working on a piece of content is located, that's where the computers are. And the computers they use are really big and really noisy. And it makes for quite an uncomfortable environment for people that are trying to very quietly master video, but even worse if they're trying to master audio. The last thing they need is all this noise around them. So back racking is the perfect situation for the broadcast industry. KVM extenders and KVM switches being used throughout. And then again, data centers, where you've got a few hundred or even a few thousand servers that you want to be able to access. But if you're going to have to do a computer build-up or something, you really don't want to be sitting in a room at 14 degrees centigrade with your coat on, with dry air, in a very noisy environment, so you're having to put earplugs in for 6 hours while you load a load of software onto a computer. A much better idea is to have that computer on a KVM system where we can go basically from the data center computer out to somewhere a lot more comfortable. People can manage the equipment as if it was sat at their desk, so it's a much more comfortable environment. Now, here's some contact details for you. I'm obviously at the top. I'm Brian Andrews, but we've also got Bo and Casper's details down there. I'd like to thank you for listening to the presentation so far, and I understand that we do have some questions raised, so if someone could begin feeding those questions through to me, I will get them answered for you. Thank you very much.
Yes, sir. Brian, thank you so much. We have a few questions. One of them going, can I go from a DVI-D to an HDMI cable?
Absolutely, 100%. Those two particular interfaces are 100% compatible with each other. They don't need any kind of conversion with regards to voltage levels and signal techniques. They are just two different connectors sending the same interface. Now, the only time that you would get problems with this is if you're outputting 4K or 8K, because HDMI is perfectly capable of transferring 4K or 8K information. DVI-D was never designed for it. Apart from that, yes, perfectly interchangeable.
Right. Got a few more, Brian. What's the difference between KVM switching and KVM matrix switching?
Okay, with KVM switching, you have a single user switching between multiple servers. So they may have 2 computers or 4 computers under their desk, maybe even a bank of 16 computers somewhere, and they need to be able to manage all of these. But it's all going from these 16 computers to one desk, to one user. With KVM matrix switching, we have multiple users, and they could be spread across a building or even a campus, and they all require access to the same servers. So with a KVM matrix solution, rather than having, say, 16 inputs from computers and one output to one user, you could end up with something like 128 inputs from different computers going to 16 separate users spread around a campus. So it's basically, the answer to your question is the number of users.
Okay. One more, Brian. Which is better for a customer? KVM over IP or direct connect KVM?
This is very much on a case-by-case basis and is very specific to the particular customer's requirements. Typically, if they're staying within one building, if the computers and the keyboards, monitors and mice are all in the same building, going direct connect will allow you to travel further distances using less expensive kit. You can still use these devices within matrix switches, but they won't be employing IP technology, so they can work out more cost effectively. However, if the customer has a powerful network that's already in place, or they have a spare network, or they wish to build a separate IP network, or they have a campus environment where they have links between buildings which are already running IP, then IP makes the best solution. So what we tend to do is talk to the customer not just about their specific application at that moment in time, but we talk to them to understand very quickly the overall background of the site, how it's laid out, where the computers are going to be located, and they could be spread around the campus, and where the users are located, and they're very likely to be spread around the campus. And then we look at what technologies are already existing, and we make the recommendations from there. So it's not an easy answer from a point of view of saying, oh yeah, IP is better, or direct connect is better. We often end up mixing and matching two types of technology, which in one of our later sessions will bring us on to the Emerald product and why that's so powerful, because it supports both. But we'll touch on that another day. But basically, it's horses for courses, as we would say, and it's matching up the correct product or products to the customer's application.
Right. Thank you. One final question, Brian, unless something else pops up. What is the difference between KVM over IP and HD-based T?
HD-based T technology that's been more designed for home use than corporate use. That's not to say that it can't be used at the workplace, but it was more designed for use at home. And it's quite a good idea. It allows you to take an HDMI signal, and that could be 4K, 3D, or whatever form of HDMI video that you require. 100 meg Ethernet as well, so that you can run a smart television. Control signals, such as infrared, so that you can have your set-top box located somewhere else apart from where the television is. And power, to power up the television from a single source, from a single Cat-X cable. So you could put all your set-top boxes in one location in the house, maybe in the loft, and a television downstairs, and you run one single Cat-X cable from the upstairs to the downstairs using HD-based T technology, and you'll receive everything you need to power, display onto that television, and it will also support 7.2 audio. So that's 7 channels of surround sound plus up to 2 subwoofers. And all of this information is just traveling down this one Cat-X cable, which is fantastic. What it doesn't do is support keyboard and mouse. So it's really a one-directional signal from the source to the screen. The only thing that runs backwards is the infrared remote control being received at the television and sent back down to the set-top box, so that you can change channels for the convenience of your chair as you do normally, whilst the kit is located elsewhere. KVM over IP technology allows you not just to send video, but also keyboard and mouse. And when we're extending a desktop, or we're back racking, we need keyboard, video, and mouse. So at that point, HD-based T isn't really of any practical use for us, which is why it was invented to be used in the home and not in the office. Secondly, KVM over IP technology will run through any switches, hubs, routers, wireless network, free space optics, whatever you may have that's supporting your IP infrastructure. KVM over IP will work through it. HD-based T will not work through any form of Ethernet switch. So if you're using IP switches, HD-based T cannot run through those switches. They will block the signal. And in fact, because you're running power down an HD-based T cable, you do need to be quite careful as to what you plug that into at the other end. So you could end up putting 48 volts into your Ethernet switch and blowing the port up. So they have very different use cases, but they are both very good technologies in their own right.
Right. I think that concludes the questions for today's webinar. I want to thank you to all participants for attending, and thank you, Brian, for taking us through understanding KVM technology better. And hope to see you all next week, same time, same place, for a webinar on Direct Connect KVM versus KVM over IP. Thank you.
Thank you very much.